Let's look at meta-analysis. So the goal of meta-analysis is to combine multiple studies. So let's say we have multiple heart attack studies run by different universities. They have different number of patients, and they're looking at the odds of heart attack for people who take the drug versus people who do not take the drug. And then we're going to compare the odds ratio in our example. So what are some of the benefits of combining these different studies? So one, it is multiple studies rather than just a one-off. Let's say instead of just a one-off finding. So for example, if we just had the finding from Cornell, for example, it's the finding says the odds ratio is 0. Actually, that should be a 1. So no difference between people taking the ratio for drug takers versus non-drug takers. So if we just looked at a single Cornell study, we'd be like, hey, the drug didn't work for preventing heart attacks. Second benefit, we can take advantage of a larger sample size and statistical power. So for example, look at the Johns Hopkins study. It looks like it's on the margin of being significant, but officially it crosses the 1 threshold, so we have to report it as non-significant. But is it due to the lack of effectiveness from the drug, or is it because it just isn't powered enough? I think part of that is also pooling your effect size. So if you looked at the effect across these different studies, they definitely vary. So if you actually start pooling the different sample sizes, you might get more accurate representation of the actual effect size. And then maybe one fourth benefit we'll talk about is, let's see, heterogeneity and representativeness. So say you're trying to make a statement about the population, but naturally these universities take patients from specific populations. Columbia, for example, is in New York City. Penn is in Philadelphia. They're big cities. There might be something related to big city patients and heart attacks versus, hey, Stanford, you got some West Coast representation. Cornell, you got some suburban representation. Johns Hopkins, another inner city representation. So if you're trying to make a statement about the general population, it's nice to get samples and representation from different city versus suburban, West Coast versus East Coast, those types of differences to make a more population level assessment. So we won't go through exact details of the meta-analysis calculation, but what it does, it aggregates the findings, in this case the odds ratio between drug takers and non-drug takers, accounting for the sample sizes, the mean, as well as the noise, the variability within each sample. So after aggregating this, you'll probably get something like, let's say your overall effect. Your overall effect will aggregate all your sample sizes, and say the mean effect is there. And since you aggregate so much of the sample sizes, you'll actually end up with a smaller confidence interval compared to like individual studies. And yeah, in terms of extra materials, you may want to look up fixed effects versus random effects, and also looking up publication bias.